Just for everyone at home, we need you to remember it's important. It's Maya's birthday today. I'm currently recording, yes. So there you go. So we need to go through how to simplify expressions. Simplifying expressions, algebraic expressions, it's all going to be on the test. So make sure that we're reviewing everything that we've done as well as this as well. Remember, what we've done in the past couple weeks is not covered. So chapter 6 is not covered on the test, but chapter 1, chapter 3 is covered on the test. So simplifying these following expressions, 4x take 7 take 9x. All right. We need to remember we need to try and group like terms together. So we have 4x. What's a like term to 4x, Duncan? 9x. 9x. And then there's that minus in front of it, which means you have to take it away.
No, or negative.
So 4x take 9x take 7. Which is negative 5x. Yep.
So you really like your colours.
Yes, I do. I love my colours.
Can you speak for the rest of the lesson like Forrest Gump?
No. So next up, we've got 7yx squared take 4y squared plus 6y squared. All right. So we've got 4y squared. What's a like term to that 4y squared, Dorsa? Yeah, exactly. And then we have to take into account the signs that are in front of them. So we've got my 7yx squared. That's got no like terms, that just stays by itself. But Charlie, what should we be writing as well? So negative 4y squared plus 6y squared, what does that get us? 2y squared. Negative 4y squared plus 6y squared gets me to 2y squared, all right? Factorizing expressions. Okay, so now we're talking about factorizing our expressions. Remember, the first thing you need to do when we're factorizing is try and find the highest common factor of the two terms. So you find the highest common factor of the two terms. What is the highest common factor here? Sam? 9. So the highest common factor is 9. So we put a 9 and then we've got our brackets here. And then I always like writing that small writing at the top and then dividing it by whatever numbers on the outside. If you don't need to do that step, if you don't need to do this, that's absolutely fine. I'm just doing it for the explanation. So it's going to get you to 9 outside of 3x squared plus 1. (27x squared divided by 9 is 3x squared. 9 divided by 9 is equal to 1. That's why we've got those terms in there. If I was to expand that out, I'd just get 27x squared plus 9, which is how we can always check our answer. Can anyone tell me the highest common factor for this question 2b?
5.
So 5 is definitely one of them. Can we take out any common variables out of both terms? Y and Z. So 5y, there we go, Z, 5yz is our common factor. So I take that out and put it at the front of my brackets. And then I need to divide each term inside the brackets by that highest common factor that I've taken out. Okay? So 5yz, that's going to get me to 3xy. Take 20, sorry, not 20, take 4. Take 4z. Yes? Again, hint, hint, flashing lights. You need to know how to factorize for the test. You need to know how to simplify expressions for the test. All right. So make sure we're looking back on how to do all these things. Today we're moving on in our lines. We're going on to gradient. Okay. So when we have a straight line, we always try and find out. We always want to know how steep the line is. So you'll often refer to us saying that one line is steeper than the other, or one line is increasing faster than the other. Well, there's a very important reason for that, and because it's important for the line. So let me just move that around. I don't want that. Okay. There we go. So we have a straight line. We also know how steep it is, whether it is sloping up or down. Is it going to be sloping up? Is it going to be sloping down? How much our line slopes is called the gradient. The gradient. Okay, and I'm just going to draw a line on my graph there. We can see that that is sloping up from left to right, and so it's important to take that into account. The definition of gradient the gradient of a line is the rate of change of y given x. And that probably sounds like a little bit of different language right now, but what that means is it's how much y changes when x changes by 1. So as x increases by 1, how much is y changing? That's what it means with the rate of change given x. Formula-wise, we can say a few different things. So the gradient it has the mathematical symbol of m. When you see m, we're talking about gradient, which really makes no sense because gradient and m have nothing to do with each other. But we can't use g because that's gravity. So we say m. Gradient is m, which equals rise over run, which equals our change in y over our change in x, which equals y2 take y1 over x2 take x1. These are all different ways where we can find the gradient, okay? Paste.
So, where it says...
Yep.
Where it says y2, y1, does it matter which?
Yes. That is why I wanted to kind of emphasize it yesterday with midpoint, that it matters which one you pick, because this one specifically, it matters which one you pick. So let's say I've got two lines here that I will draw from my origin. Remember, the origin is the point where the coordinates are 0, 0. So I've got two different line segments drawn here. So for the top one, remember that the gradient is always equal to the rise over the run. So I'm going to start from this one point here. How much do I go across? If we can zoom in, I've gone how many units across to get to that endpoint? 4. I've gone 4 across. Then I've gone 4 up. My rise is 4. My run is 4. So rise over run is equal to 4 over 4, which is equal to 1. So the gradient of that top line there is just equal to 1. Y increases by 1 as x increases by 1. Other way around. Well, here my run is still 4. I'm still going the exact same distance across. But now instead of positive 4, what will my rise be? Negative 4, because I'm going 4 down. So for my bottom line, gradient equals rise over run, which equals negative 4 over 4. And that's going to equal negative 1. So the rise is how much I go up or down, and the run is how much I go from left to right. Now that from left to right is really, really, really important.
But isn't there 2 lines there? Oh wait, there's 2 different things.
The gradient is always... Is that right? Gradient is always from left to right.
It's from left to right.
From left to right. We always read gradient from left to right.
Look how you wrote it.
From left to right.
So how do you know which y or x you have to start with?
So that's what I'm going to talk about. Since we always read gradient from left to right, the most left point should be your point 1, and the most right point should be your point 2. So for example, I've got this point here, and I've got that point there. This should be 1, and that should be 2.
So, but it says you start with 2.
Yeah, because you start with the y coordinate at the second point,
Yeah, so
and then you take away the y coordinate of that first point.
So you start with the one that's furthest to the right.
Yes, because you start with the one that you've labelled 2. All right? Sarah, you good if I go there? Yep. So, a couple of examples. Find the gradient of the lines. Put that in again. Shrink it down a bit. So I'm going to draw 3 lines here. Okay. So we've got 3 lines now drawn. Oh, actually, I'll continue this line on. That should be continued on. There we go. And I need to try and find the gradient of all of them. I'm going to start with my blue one. So the gradient of my blue line equals rise over run. And just because I know that that's a bit difficult to see from there, I'm going to tell you that that point there is 2, 6. And that is 0, 0. So how much have I gone across? What is my run? 2. I've gone across 2 units. That's 2. How much have I gone up? 6. So my rise is going to be 6. My run is going to be 2. So my gradient is equal to 3. Now the vertical and horizontal lines is where we need to start thinking a little bit differently. Horizontal line. If I stay flat the whole time, how much am I changing up or down? 0. I'm not going up, I'm not going down. So for my green line, my rise will be equal to what? 0. And what's anything divided by 0? It's just 0. 0 divided by anything is 0. I'll say that the wrong way around because I said it wrong. 0 divided by anything is always 0. So the gradient of a horizontal line, is 0.
So, in your videos, you should add a 5-minute long intro of just your face.
No, I'm good, thanks, Bryn. People don't want to see my face for that long. Now, for my vertical line, you can see that I'm always going to be going up or down, but I'm not going left or right. So what does that mean about my run? What does that mean in my change in horizontal? How much am I changing? 0. So it's rise over 0. Are we allowed to divide anything by 0? No. That's a big no-no in math. You can never divide anything by 0. It's undefined. So when we have a vertical line, it has an undefined gradient. I always like to think about it like I'm walking. So I'll just finish writing this first. The gradient of a vertical line is undefined. If I'm walking, let's say I'm walking on flat horizontal ground, it's not going to get any harder or any easier because it's always just going to be flat. If I have a positive gradient, if from left to right I'm going up, it's going to get a little bit harder every time because I'm walking up a slope. Same way if I'm walking downhill, it'll get a little bit easier because I'm walking downhill. And if I'm walking just straight up, you can't walk up a wall unless you're Spider-Man. And I don't think anyone's Spider-Man here. Okay, Duncan, you can bring in that costume tomorrow. So, always just remember, we read gradient from left to right. It's the rise over the run, and that is how we calculate it. Now, we can figure out using rise and run, or we can also figure it out if we have 2 points on a plane. So if we have 2 points, let's say one of them is going to be here, and one of them is here. Can you guys clearly see where they are on the plane from where you are? What is that bottom point there? What's the coordinates of that bottom one, Sophia? 5, -1. Claudia, what's the coordinates of the top one? Okay, so we're going 1, 2, 3 across. So negative 3. 1, 2, 3, 4 up. So negative 3, 4. And now we can always draw a line between 2 points. So let's just draw the line in. We can now find the gradient of the line because we have the 2 points. So it equals rise over run. Or we can do our formula of y2 take y1 over x2 take x1. Now this is where making sure the 1 and the 2 is really set in stone. We read gradient from left to right. The point that's most on your left should be your point 1. The point that's most on your right should be your point 2. So that is clearly point 1, that is clearly point 2. The y value at point 2 is negative 1. Then we take away the y value at point 1, which is 4. And then the x value at point 2 is 5. Take away the x value at point 1, which is negative 3. Can someone please tell me what is negative 1 take 4? Duncan. Negative 5. We get more negative. Maya, what's 5 take away negative 3? What happens when we take away a positive? Yeah, 8. We add that negative. So the gradient of the line is negative 5 over 8. You can absolutely have a fraction for a gradient. Okay, that is okay. You leave it like that. And that's all there is for that. And again, always just remember gradient from left to right. Any questions? Okay. Remember again, this material will not be on this test. It will be covered next term, most likely in the exam, because there will just be too much content to put in the one test. The test on Monday is talking about algebra and measurement. So when we're talking about surface area, when we're talking about volume and all of that stuff. Okay? For those of you watching at home, go into the calendar and the link for the 2018 test will be there. That's what I'm giving out today. And that will be your work for some revision. Yes, there is a calendar in the course information section. So I've got a course information calendar. That's where I'm going to put all information from now on, just to accommodate people who are working from home. If you click these links, it'll take you to everywhere you need to go.